And these are going to be a series of quick little 5 or so minute talks from these startups. And at the end, we'll have a little time for Q&A. We're going to pass it over to Mary Johnson of Polaris MEP 401 TechBridge to lead the discussion and to introduce our startups.
Thank you, Avi. Welcome, everybody. Thank you for staying with us. I know as we get into the last hour of the event, it's tempting to just go find something to eat. I am Mary Johnson. After 3 years of working with Polaris MEP with small and mid-sized manufacturers, I have recently taken on the job of leading the 401 TechBridge. We are working closely with the Northeast TechBridge to help commercialize and connect the Navy into industry, but also have a mission to promote the growth of the advanced materials sector in Rhode Island. So working with composites companies and textile companies to explore opportunities in wind energy and undersea technology that isn't related to the Navy, and other projects that you'll see and hear a lot more of as we get off the ground. We're really in a launch startup phase now. And you'll be hearing more from us, the 401 TechBridge, in the next 90 days, 120 days, as we continue to grow. I'm here today with 4 companies that are Rhode Island companies that have worked very hard and are very innovative in terms of R&D, both with military contracts and moving into dual use. I'm going to let them do, I'm going to do a brief introduction of each of them, and then we'll let them take over. In most cases, they have slides as well. So we will have some flipping back and forth of the screens. We're going to start with Ed Bard from Response Technologies. Ed is a former U.S. Army officer, and he spent 20 years in operations and product development and technical business development. He has led operations in business development for 3 specialty urethane foam chemistry and 3D molding and manufacturing startups, and has significant experience in the production and development of innovative solutions. Ed, there you are. I can spot you now. If you want to take over the screen and put your slides up, and then we look forward to hearing about Response Technologies and the work that you're doing.
How's everybody doing? I thought about the slides and thought better of it, especially in light of time. Just more kind of on the story side for those here. We were one of those 2-person startups that we heard a couple of. Myself and David Petty started Response Technologies in 2015, and we grinded on both the commercial side and the technology on the technology side. And the thing that we have heard over and over again, probably here as well, is that we foolishly thought that once we got our first SBIR, and we'll walk through that story real quick, that great, you're selling to the military. It just doesn't quite work that way. So we started in 2015 and got with Mass Challenge, and also won. We were looking for any traction we could get, and we won the Sikorsky Innovation Challenge, now Lockheed Martin, and we started working with them on the H-60, the Black Hawk helicopter, for crash-worthy fuel tanks. And these are tanks that need to survive a 65-foot drop and self-seal against bullet fire. That was it. We were just kind of tossed into the deep end, and all right, go solve the problem. Here's a mil spec. And all the stuff that you want, you know, what's the problem? How can we do a little bit better for you? All that type of stuff. It was a bit of a challenge. So what we ended up doing was we first got with PTAC and said, all right, how do we start mining information on NSN part numbers, market size, all of that? And they got us on one of those my bid searches, so that every day keywords would pop into our mailbox, and a lot of them, you know, it didn't quite work out, but every now and then, starting in 2016, we'd get a hit. All right, here's a fuel cell. and we'd be able to go grab it, and then we'd have an NSN number, start to get who the manufacturers were, what the prices were on it, and all of that type of stuff. So we just really mined data for 3 years, and then looked at different programs and started to really get a buildup of contract officers and part numbers. We then, well, my job was then I would cold email all of the contract officers and introduce the company and say, hey, we're Response Technologies. We're working on fuel cells. Here's what we understand. How can we help you? And we'd start to learn from the contract officers what their problems were, what they needed, and then we'd get referrals to technical points of contact. And actually, one time we were talking to a mechanic down at the base, so that was kind of cool. But it really just took biz dev grind of slowly working forward, and one day at a time. You would think, we thought wrongly, that the DoD has this giant database with that they can hit a button and get you all the information in the world, and it doesn't quite work that way. So if we can help anybody on how we did this and some of the tools that we've used, we've learned a lot of what works, what doesn't work, and we're always willing to learn more because tools are out there and changing. Happy to help.
Thank you, Ed. That's great. Now we're going to move on to Clare King, who is the president of Propel LLC. Clare has had an extensive career in technical textile development and garment production development. Her current company focuses on bridging the gap between textiles and technology, with a particular focus on protection for U.S. military personnel. Clare, I'll let you take it from here.
Okay, so nice little introduction, Mary. I always kind of laugh when I get called a startup. We're in our 15th year. We are not a startup, but every project is a startup. When I started this business, it was really with a focus on the Department of Defense and the fire service, because most of the technical textile development that was going on was very centric to a specific textile manufacturer. And there wasn't really any company looking at the problem and going backwards and saying, okay, how am I going to solve the problem? And it may take technology from new places, it may take new technology, it may take adapting current technology. So that's really our focus. We're 5 people. We do a lot of collaboration with large companies, and we've worked with some very large companies. We also do a lot of collaboration with small companies. And in our history, we won our first SBIR in 2012. And since then, we've had 6 phase 1s, 3 phase 2s, 3 phase 3s. I'm currently writing a sequential phase 2 for anyone who is familiar with the terminology. That means somebody liked what we did on a phase 2 and wants to fund their own phase 2 around it. That's for the Marine Corps. And we're waiting to hear on a phase 1 final at the moment as well. So I thought I'd just quickly go through what we've got out of some of our SBIRs, the 3 phase 2s that 2 of which are complete, but we're continuing to do follow-on work, and 1 of which we just started. And I'll talk about, particularly in that one, about how it's pivoted to COVID-19 solutions. So the first phase 2 we won was with the Navy Clothing, Textile and Research Facility, which is up at Natick, Massachusetts. Everybody thinks of the Natick base as just being the Combat Capabilities Development Command, what used to be known as NSRDEC. But in fact, all the services are there, and they operate their own individual offices. And if you want to find special ops, they're in a locked basement, and they won't let you in with your cell phone. So we have this one that was really looking at, can you assemble clothing without needle and thread using existing and new technologies that were manufacturable? Were they manufacturable is what we were looking at, and what technologies did we needed to develop to make garments without needle and thread. And the whole goal was to make everything lighter and less bulky. So the top left hand, you'll see the garment that we delivered at the end of this to the Navy, and it was 30% less weight and 50% less bulky than the existing garment that it replaced. And then we just last winter did a phase 3 in the cold temperature Arctic protection system with the Army, looking at adding that into cold weather clothing, and again demonstrated significantly reduced weight. Now, why is this important? Well, moving stuff around costs money, but also wearing stuff that's heavy costs energy, so human energy. So if your clothing is lighter and less bulky, you can perform better on the job. And that led also when we were still in phase 2, to the phase 3 for the big Silver Man. And we are in the process of delivering that right now. And that's for inside submarines, for damage control if there's an accident and there's a steam leak. And it's a $5,000 system, because there's over $2,500 of materials, many of which we developed in that suit. But it was half the weight and than the existing system, and for the first time could be worn by anybody from 5'2" to 6'4", self-adjusts. And there are many women who are submariners who could not wear the existing system. So this is considered a great success. ONR funded the phase 3, and now the bit that Ed was talking about getting the order in many ways. We were as a small company, very involved in getting a GSA contract for that, not a DLA contract, but GSA, and I have a 5-year contract to deliver that. So that's pretty exciting, and we're hoping there'll be more contracts. So our second phase 2 was on electronically enabled textiles for data and power transfer. And that's Birgit Leitner up in the left-hand corner, who's my head designer, testing our shirt that integrates electrical yarns we developed. And the whole purpose of that shirt, which was a demonstration of the technology we developed, is human performance monitoring, both for the Navy SEALs in the SEAL delivery vehicle, and now NavAir has got extremely interested in what we've done. And we are slated, we would have done it by now, for human performance testing in NavAir facilities down in Eastern Maryland as soon as they can reopen. And we've developed some textile cables from that, which are getting a great deal of interest. And that led to another SBIR that we won for a self-activated heated aviator boot. That's a NavAir Air Force project. And we've actually built into that boot a self-activated heating system so that when your toe goes below a certain temperature, it switches on, and it's going to last for up to 6 hours at -49F. So each SBIR has other outlets to it, and they connect into each other. And we have linked up with a commercial company that builds boots for the Air Force, but also builds boots for the mining industry, etc. And we expect eventually to bring that to market through them. So the last one I'll quickly talk about is this pivot to COVID-19. If some of you were on this an hour or so earlier, Christian mentioned this and Mary mentioned it. So we were very quickly pulled into how are we going to solve some of the issues for COVID-19. And through the Rhode Island Textile Innovation Network, which I'm part of, we began making cloth masks within we were in production the first week in April. And by the end of May, we'd shipped 55,000. And that getting so deeply into cloth face covers, cloth face masks so quickly led me to doing a lot of research on the FDA rules, the CDC, what masks are supposed to do, understanding surgical masks versus N95s. And we were awarded a phase 2 for 3D knitting on March 19th. And that was supposed to focus on additive manufacturing methods for creating clothing individually with delivering a new flight deck jersey to the Navy. And they quickly added in a $250,000 add-on to the within 2 weeks of me getting the phase 2, and asked us to pivot towards taking what we understood about cloth face masks and making a 3D knit mask. And now we are involved in what I would call a very detailed approach to thinking about not an N95 as it exists, but something that will perform like an N95, but could be worn for long periods of time. So this would integrate filtration into a structure that we would build with 3D knitting. And we have partnered up with the industrial design company Loft in Rhode Island for that. And we have other subcontractors in that as well. So this has all happened very quickly. And then the last thing was that on May 21st, we won a 1.6 million piece contract, which is worth about $7 million from DLA to deliver our cloth face masks that didn't even exist 2 months prior to that. So it's been insane for the last couple of weeks, but it's all very much driven by our relationships in the SBIRs, who knows us, what they know we can do, and then our very broad relationships domestically, because all of this is domestic manufacturing, domestic fabric. I got the fabrics from Darlington in Westerly. I knew they could turn on a dime. Northeast Knitting and Stretch Products in Pawtucket made the elastic. We had relationships with factories. I hired a logistics expert that regularly works with Patagonia, who's one of our partner companies we work with a lot, and we got it going almost instantly. So it can be done. We can do great manufacturing here, and we can do quick innovation. With that, I'll turn it back to Mary.
Terrific. Thank you very much, Claire. Moving on, Jim Owens. Jim, you want to bring your slides up and make sure your mic's on, is the founder and principal of Nautilus Defense. They are a Pawtucket-based engineering firm that also focuses on advanced textiles. They also work on composite integrated systems. Jim has over 12 years of experience leading the development and transition of mission critical systems from labs to harsh operational environments. Jim, take it away.
Great, thanks, Mary. Can everyone hear me okay? Great, okay. So today I'm just going to speak briefly about our recently finished phase 1 AFWorks STTR project titled In Situ Composite Health Monitoring for Hypersonic Vehicles. For this project, we're teamed with local company Goetz Composites and also the University of Rhode Island to develop an integrated system to continuously measure and characterize the performance of hypersonic vehicles. Ultimately, the system will provide actionable outputs to inform engineering, operational, and sustainment decisions and accelerate the readiness of hypersonic capabilities. So this project kicked off on March 5th, and it's only a 3-month phase 1, so we had to move fast, and in the midst of everything, it was really important that the team was local to Rhode Island. So that turned out to be a really good move and allowed us to really quickly design, build, and test a series of prototypes. Within these efforts, Nautilus was responsible for the system architecture, data acquisition, and processing hardware, and the functional fiber reinforcement that was integrated into the composites built at Goetz. URI then tested these systems at their dynamic photomechanics lab doing experimental testing and also numerical multi-scale simulations. So this, again, it was really important to have a really tightly integrated collaborative team that was able to design, build, and test things very quickly here in state to meet our customers' expectations for this project. So one of the other ways that we were able to move quickly within this effort was to develop the prototype systems to validate the architecture using carbon composites. Now, those aren't really suitable for use in hypersonics because of aerodynamic heating present during hypersonic flight, but we were able to source and identify materials that would be suitable for use in hypersonic systems that will be used during phase 2 efforts to develop the next round of prototypes. And that's anticipated to begin on August 3rd of 2020, thanks to the AFWorks program moving very quickly relative to typical funding timelines. So also important within these efforts in phase 2 will be taking those outputs and building structural digital twins that will allow us to actually take what we've learned from the system and integrate it into other systems, such as predictive maintenance platforms and autonomous recommenders or control systems. So we're working with the Air Force Research Labs Hypersonic Vehicles Directorate at Wright-Patterson Air Force Base, and also the Navy's Hypersonics Group at Naval Surface Warfare Center Crane Division. So while this system, again, is developed specifically for hypersonic solutions, the underlying architecture and manufacturing approach both show a lot of promise for transition to a broad range of instrumented composite systems for use in other missions. And one of the really key components to the success of this project, both in phase 1 and beyond, is the fact that our team, just in Rhode Island, is designing, building, and testing every component of this system. Obviously, we'll need to work with others when we're finally doing vehicle integration later on. But for now, to actually validate the system and develop the product that can be integrated into a larger composite laminate, we're doing all that in state, which has been really exciting. So thanks.
Thank you, Jim. And I think both, all three stories so far have really stressed the value of the network here. Because we're so small, there's a lot of interaction. There's a lot of collision with people where they're able to pollinate new ideas, act on things quickly, and help solve problems. I think that that is something that the 401 Tech Bridge, certainly in partnership with the Northeast Tech Bridge, hopes to leverage and make those connections stronger and bring in new companies, working with companies like groups like the Mass Challenge to help startups get started, connecting these companies more into the primes, that there are lots of opportunities here for this ecosystem to continue to get better and stronger and be a really significant, an even more significant driver of the Rhode Island economy. And finally, I'm going to introduce Chase Hogoboom, who is the president of Goetz Composites in Bristol, who was one of the partners on Jim's project. They are an advanced manufacturing company that specializes in the design, engineering, and fabrication of integrated carbon structures, which perform in challenging environments. So I'll turn it over to you. Thank you.
Well, thanks. And I just want to thank the effort for putting this program together. I wasn't exactly sure the content or participants going into it, but very much exceeded expectations. And it was funny, a couple weeks ago, was giving consideration of whether we wanted to stay in our current space and or move to a different location that would maybe better suit our needs. And there was a very brief moment where I gave some very quick thought about moving to Massachusetts, and that idea was squashed about 5 minutes after, but was just pleasantly reminded again why I enjoy being here, and I'm glad that we are here. So this is very cool. So our organization company is in Bristol, Rhode Island. We specialize in engineering, manufacturing, advanced composite structures, but we also do a lot of integration of systems, whether it's control systems, propulsion, sensor technology, and then not only installation, but also the engineering and design of some of these things as well. So as far as relevant projects, we're doing two really cool things with the Navy right now. One is an ONR Challenge Award, which was really our first formal engagement with the Navy, which maybe took place about 18 months ago, from the first announcement to the eventual award, and now we're going through the process of development and so forth. But that's for a full ocean depth, which is 600-meter composite pressure vessel. And other very cool engagement is with NUIC and NAVSEA, their experimental payloads group, where we worked with the team to design, fabricate, and do some integration of systems for a UUV, which operates up to 600 or 6,000 meters. And that's really been a unbelievable symbiotic relationship where we took a concept and brought it to in the water testing in under 12 months. And in fact, in a couple of weeks, we'll be back in the water for a second round of testing. And it's just such a great group of folks that has allowed this to move very quickly. But with those two projects, we've undertaken some relevant side projects, and the state of Rhode Island has helped us out with an innovation voucher, and we're working with URI, their engineering department, to analyze and then create a scalable model for underwater composite structures, specifically pressure vessels. And then as we continue doing more and more stuff underwater, we're giving lots of opportunity to just do a lot of testing of bonds, 3D printed components, other materials, smaller structures, and assemblies at 10,000 PSI, which is about 6,000 meters deep. And it's all in an effort to understand end-of-life determination for some of these materials and manufacturing processes. So one of the things, let's see, how do we advance the slide? Okay. There are two things I just would like to talk about in what's been a very eye-opening experience for us in working with the Navy. And the first item is understanding who the beneficiaries are, and then trying to understand dual use of whatever it is we're developing. And so this is I guess, a flow chart of something we developed at the beginning of the project. This is specifically what an example for the ONR project we're doing. But it's a very helpful roadmap that I update every single month as we develop and go through the process and present various topics to ONR. And so this helps us keep our eyes open. Not only, okay, we're focused on solving a specific problem, but then, it keeps reminding us, okay, well, how is this going to be helpful to other people? And so we have commercial and research applications as well. And so this is just a very general outline that's been helpful in guiding us and keeping us focused on what we're ultimately trying to do. And then just another tool that I've enjoyed using and developing is really working with the beneficiaries to understand priorities and goals. And so in this particular case, okay, well, we have a base product or something that we're trying to use to solve a solution. And so this is, again, kind of a thought diagram. Okay, well, how are we going to do it? Is it through geometry, process, environmental protection, life cycle, materials? And by working with our beneficiaries, we were able to hone in on 4 items here that we continued to develop and explore. So anyway, I unfortunately cannot speak more specifically about some of the project type stuff that is really exciting, but I've really experienced or really enjoyed working with the Navy in developing some of these tools to try and not only solve their problems, but problems other beneficiaries really didn't know existed, which has been great. So anyway, that's what I've got. So thank you.
Thank you, Chase. I want to thank all of you for taking the time to share your stories. And I want to add that part of the partnership last year, when the ONR started looking at the prize challenge award, and the Composites Alliance and Polaris worked together to host an event where the engineers who were working on the projects that were about to be released by the Navy came in and talked to a group of composites companies from Rhode Island, kind of about what the challenges were in a little bit more technical detail. There were 3 awards for that challenge, and Rhode Island companies won 2 of them. So Response Technologies won 1 of them, and Goetz won one as well. And so that really highlights the innovation that is happening here, that of a national challenge program that was meant to attract kind of the best and brightest into the underwater research area. Rhode Island kind of almost swept the field. So none of this really would be possible without years of collaboration that has been happening behind the scenes, both between the companies, organizations like Commerce, certainly Senator Whitehouse, who has been driving the promotion of the composites and the textile companies in Rhode Island, and has been saying for years, you know, you need to have a trade association to work together. You need to help these companies get together more often. And RIMTA, Susan Daly, who was here earlier, runs the Composites Alliance. I did the startup for the Textile Innovation Network. And we're really looking forward to working together to just keep this momentum going, partnering with URI, with the other universities in the region, and with the Navy, and with lots of other groups. And we're always happy to talk more about it. Yeah, I was gonna say, I would like to jump back to Ed for just a second to talk about the COVID response that they've been doing. Because that's really been a terrific use of additive manufacturing. And also has implications for a lot of commercialization. And I know he was so conscious of the time that he probably didn't share that story.
I did not. I was trying to, for once in my life, follow the rules, Mary. And I could tell my wife that I actually did once. Similar to a little bit with Claire's efforts, we have worked with our 3D textile machine to develop really additive manufactured face masks. And what we're trying to work towards is actually getting them to a level 1, level 2, or level 3 surgical level, such that then these can be put as say on an aircraft carrier or forward support. So what happened with the Theodore Roosevelt, where they had a mass outbreak very quickly, they were just sewing or stitching up cloth masks to just do whatever they could, and it just spread like wildfire. So doing the product development to build that up such that they could actually print surgical masks on the machine for their soldiers and have it washable is kind of the value proposition that we're working with the Navy on.
Thank you.
Thank you guys so much for all you've done, and you know, being kind of behind the scenes and part of it for the last 6 or 7 years. It's really impressive to see, specific to what you're talking about tonight, all of this come together and the robust ecosystem that you've all created. Congratulations to everyone, and keep up the good work. This is just unbelievable.
And in turn, Avi and Tuni, thank you so much for what you do in our community, because while this is all very interesting and informative, this is the world we live in, but this is not the collective everybody is aware of. So evenings like this are so critical to being able to share these stories, to let each other know what's working and how things are working and what's even possible. So thanks everybody, and thank you for making this happen.
I've seen even in the last 2 years, the bridge that you're continuing to build between NUIC and the private sector. And, you know, with programs like UTIC and Synedia, you're all playing such significant roles in creating the ability to have more stories like we've heard tonight continue to happen. So thank you.